Learning multiple classes. In our example of learning a family car, we have positive examples belonging to the class family car and the negative examples belonging to all other cars. This is a two-class problem. In the general case, we have K classes denoted as Ci. I is the index starting from 1 to 3, K, and an input instance belongs to one and exactly one of them. The training set is now of the form x is equals to the tuple x to the t and r to the t, where t is starting from 1 to n, and where r has k dimensions. And ri to the t is equals to 1 if x to the t is in Ci, and ri to the t is equals to 0 if x to the t is in Cj, such that j is not equals to I. So an example is given in figure 2.9 with instances from three classes: family car, sports car, and a luxury sedan. In machine learning for classification, we would like to learn the boundary separating the instances of one class from the instances of all other classes. Thus, we have view a K-class classification problem as K2 class problems. The training examples belonging to Ci are the positive instances of hypothesis Hi, and the examples of all other classes are the negative instances of Hi. Thus, in a K-class problem, we have K hypothesis to learn such that Hi of x to the t is equals to 1 if x to the t is in Ci, Hi of x to the t is equals to 0 if x to the t is in Cj, such that j is not equals to I. The total empirical error takes a sum over the predictions for all classes over all instances. That is the expectations of the set Hi, where the index I starting from 1 to k, conditioning on x is such kind of expectation, is equals to the doubling summation, where the outer summation is summing for index t starting from 1 to n, where the inner summation is summing for index I starting from 1 to k. And what's the inner term? The inner term is the one function for distinguishing whether Hi of x to the t is not equals to Ri to the t or not. So for a given x, ideally only one of Hi of x, I starting from 1 to 3 until k, is 1, and we can choose a class. But when no or two or more Hi of x is 1, we cannot choose a class. And this is the case of doubt, and the classifier rejects such cases. In our example of learning a family car, we used only one hypothesis and only modeled the positive examples. Any negative example outside is not a family car. Alternatively, sometimes we may prefer to build two hypotheses, one for the positive and the other for the negative instances. This assumes a structure also for the negative instances that can be covered by another hypothesis. Separating family cars from sports cars is such a problem. Each class has a structure of its own. The advantage is that if the input is a luxury sedan, we can have both hypotheses decide negative and reject the input. If in a dataset we expected to have all classes with a similar distribution, shapes in the input space, then the same hypothesis class can be used for all classes. For example, in a handwritten digit recognition dataset, we would expect all digits to have similar distributions, but in a medical diagnosis dataset, for example, where we have two classes for sick and healthy people, we may have completely different distribution for the two classes. There may be multiple ways for a person to be sick reflected differently in the inputs. All healthy people are alike. Each sick person is sick in his or her own way.